what are the patterns of the bone fracture? Yes, so the bone will fracture differently depending on how the load is applied. Yes, so in which direction it is applied, whether it's compressive stress, whether we add rod rotation some, so whether it's mainly shear stress. So different. We also need to remember that bone is anisotropic because it's composite, so it will act differently also, and it has different strength. It will fracture differently depending on direction of the force. So compressive load. Compressive load on the bone produces oblique fracture. Why oblique fracture? Because, as we said previously, the bone is very strong in compression, but it's weak in tension and especially weak in shear stress. And the shear stress is the biggest in the 45-degree angle to the compressive loads. Yes, so like this. And generally this plane okay. The bending load. In the bending load is quite complicated. Yes, there are a lot of different things that may happen in this case. We can have bending load with additional compression or without. And this leads to fracture, comminution, and a butterfly fragment generally. What is torsional load? A torsional load produces a spiral fracture. Yes, as we remember, in torsional load, this shear stress was also the biggest in a spiral that gets around the center of rotation, of the axis of rotation. And this is the very nice picture. Yes, so in case of the tension, it's just transverse. Yes, we rip it off. Very simple. In case of compression, we remember we have this 45-degree angle because there is a position of the biggest shear stress. In case of the bending, we just, as you can see, we are getting in this direction, yes? So here we have the compression, but the bone is strong in compression. Here we have the tension. In point of the tension, it starts and then propagates. Here we have the bending and compression. What does it change? It changes that in this point, in this area, the compression is very big. So it starts to happen exactly what here. So we have 45 degrees of the big shear stress and then the normal tension here. Yes, so there are 3 points of the propagation that meets here. And then we have a torsion when we have the spiral fracture. Yes, so we are adding some additional force. Yes, we also have this spiral force. And here we can see nicely how the bending, how the butterfly fractures is happening. Yes. And here it nicely shows this spiral fracture. In case of the children, we have a very special situation, but about this in the next video.